and how are you, my kids? I wish that you are fine and being safe while being home. So just I want to inform you that from the next coming lecture, you will be, let's say, you will meet the conference online. You should first download the Classroom, Google Classroom on your mobile or on your laptop. Then move immediately to download the Meet application. Okay, I will send you the code and I will share the meeting conference. Okay, and this one should be online. Okay, so again, Mr. Sultan with you. Today we'll continue the matrix equation and matrix transformation. Okay, so let's start, my kids. Here is Saturday, 5 April 2020. Okay. So, matrix equation means what? A matrix equation. Okay. For example, if it is given that the matrix A of order 2 by 2 minus 1, 0, 2, 3, and the matrix of order 2 by 2, 3, 0, negative 1, 4. The question is, if the product of A, B, the product of the two matrices is 2A, negative B, C, D over 3. The question calculate the value of A, B, C, and D. Calculate the value of A, B, C, and D. Okay. You already know, my kids, how can you calculate the product of matrices. You multiply the first row by the first column, then you multiply, to find the first entry of the product, you should multiply the first row by the first column, then the first row by the second column, then move to the second row by the first column, and the second row by the second column. That is how to find the product of two matrices. Let's do it. Okay. For example, here we have what? Okay. We have the matrix A times B is negative 1, 0, 2, 3, 3, negative 1, 0, 4. Is a 2 by 2 matrix, and so B, the matrix B is a 2 by 2 matrix. Therefore, its product should be a 2 by 2 matrix, my kids. Okay? And if we suppose that A times B is equal E11, E12, E21, E22, E11, my kids, is the first entry. Okay? First entry. Okay? And this one is the second. This is the or let's say the second entry, okay? And so on. So we should find the value of E11, E12, E22, and E11 and E21. We should multiply this one, my kids. Look, I will multiply the first row by the first column. Means what? Means E11 is equal to negative 1 multiplied by 3 plus 0 multiplied by 0. Okay, let's see the first entry. The second one, it will be negative 1 multiplied by 3 is negative 3 plus 0 multiplied by 0 is 0. Negative 3 plus 0 is negative 3. Okay, the next one, my kids. What is the value that is lying on the first row, second column? The first row, second column. The first row, second column means I will multiply minus 1 by minus 1. Then I will make plus 0 multiplied by 4. Okay. I will multiply the first row by the second column. So negative 1 multiplied by negative 1. Negative 1 multiplied by negative 1. Plus 0 multiplied by 4. Plus 0 multiplied by 4. 0 multiplied by 4, my kids, is 0. No need to write. Okay? Then negative 1 by negative 1 gives 1. Okay. So we found the value that lies on the first entry, the first column. the first end and the first row, the second column. Okay, for the column, the row 2, column 1, row 2, column 1. This is row 2, and this is column 1. Okay, I will multiply 2 by 3, then I will add 3 plus 0. So, what is it? 2, 1 means the second row, first column. It will be 2 multiplied by 3, 2 multiplied by 3, 2 multiplied by 3, plus 3 multiplied by 0, plus 3 multiplied by 0. 3 by 0, my kids, is 0, no need to add. So 2 by 3 is 6. Okay? Then, for the second row, second columns, I will multiply 2 by -1, then I will add 3 multiplied by 4 to find the value that lies on the second row, second columns. So means 2 multiplied by -1 plus 3 multiplied by 4. Okay, 3 multiplied by 4 is 12, my kids. 2 multiplied by -1 is -2. -2 plus 12 is 10. So now I found what? I can write the product of these two matrices. Therefore, the product of the matrix A and matrix B is in fact E11 means row 1, column 1, E21 means row 2, column 1, E12 means row 1, column 2, and E22 means row 2, column 2. Is what? We told -3. Then 1, okay, then 6, then 10, okay. So, the purpose of this question, my kids, is to find the product, is to find A, B, C, okay, and D. So, we move. We will try to equate as this matrix. This matrix is the product of AB, isn't it? And this one is a given from the first, is a given. The product of AB is 2A negative B, C, D over 3. So I will try to equate what? To equate the entries or the elements for both matrices means -3 equal to A. Okay, means here -3 equal to A. -3, my kids, equal what? Equal to A. Then what else? -1 also equal -B. Okay, -1 equal -1 equal -B, and C equal, this is 6, my kids, C equal 6, okay, and C equal 6, this is by inspection, okay, and the last one, D over 3 is equal to 10, why? Because we were equating what? The entries or the elements of this matrix to the next one, okay? And D over 3 equal what, my kids? Equal 10. So, from this we can say that I will divide this by 2, and this is by 2. So, A equal -3 divided by 2, and B equal -1. B equal -1. And C is the same, equal 6. And D, my kids, cross multiplying, this is divided by 1. So 3 multiplied by 10 is 30. And 1 multiplied by D is D. So these are the value. Okay, A equal -3 over 2, B equal -1, C equal 6, and D equal 30. Okay. Now equating corresponding elements means, as we did before, -3 equal to A, this one means what? Means A equal -3 divided by 2, okay? This is equal sign. Then we told that 1 is equal to -B. or negative b equal 1. Okay? Means b equal negative 1. Then we explained that by inspection 6 equals c. 6 equals c. This is by inspection. Okay? And d over 3, my kids, is equal to 10. Then I use cross multiplying to write d as a subject. Okay? So this is d divided by 3 equal 10. You can write this as 10 divided by 1. Then multiply d by 1 is d. And 3 multiplied by 10 is 30. Okay? So d equals 30. Okay? Then good boy. Okay. Matrix equation. Matrix equation. Sorry. Matrix equation. Using what? Using a matrix equation to solve a pair of simultaneous equations. Okay, to solve a pair of simultaneous equations using the matrix method, we must first convert the pair of equations to the matrix form. Okay, this done by extracting the coefficients of the variables to form a 2 by 2 matrix. To form a 2 by 2 matrix. Okay? A 2 by 2 matrix. This matrix of coefficient multiplied by the matrix AX B. Okay? Multiply by. Okay? The matrix here, I mean the matrix A, B, C, D. Okay? Should produce the left-hand side of the matrix equation as shown in the example below. Okay, let's see. Okay, for example here my kids, using a matrix method, we will solve for x and y. We have two simultaneous equations, So I will try to solve these two equations and to find the value of y at the same time, okay? Meaning that you will use the method of elimination, okay, to write an equation in terms of only one variable, or to substitute and write equation 1 or equation 2 in, let's say, in terms of y or x, with one variable. Okay? You already know how to, let's say, solve simultaneous equation using what? Using method, elimination method. Elimination method or substitution method. Or you can use it graphically. You already know about this. Okay. Or this is algebraically. And graphically, my kids, you will just plot the points of the first equation and the second equation, then see the intersection of the two lines. Okay, so here my kids, I will try to write x plus 3y equal to. Then I will try 4x equal minus 3y equal 3. This is called what? Equation, simultaneous equation. I will try to perform a matrix equation or to write them as a matrix equation. I will label as x is a column vector, x, y. This is a matrix of 2 by 1, 2 rows by 1 column. Okay? Then 2, 3, I will write also as B. B is a matrix that contains the first row. The first column is 2, and the second row, first column is 3. This is also a matrix. Is a matrix or column vector. Okay? Of order 2 by 1. Why 2 rows and 1 column? This is also a matrix of order 2 by 1. Okay. I will try to use matrix. I will try to use this as matrix equation. Means I will write 1, 3, and 4, negative 3. Multiply by the column vector x should be equal to 2b. Okay. This is how can you solve this one. Okay. So, erase all. Look here. The matrix equation is what? 1, 4, 1, 1, 3, okay, or 1, 4, 3, negative 3. And this is called what? The x. The x is the x column vector. And this one is labeled as the matrix B. And this one, my kids, is the matrix A. So, from simultaneous equation to write, let's say, using matrix equation, this one can be written as AX equal B. Okay? Our purpose is what? To find the value of the column vector. To find the value of the column vector, this X. Okay? The column vector X. Or the matrix of 2 by 1 as an order. Okay. Because A is a given and B is a given. Okay? So, first of all, the first step, my kids, we will rewrite the matrix equation. Okay, this is the matrix equation. 1 times x is x. 3 times y is 3y. So 1 plus 3y equal to. Okay, means x plus 3y equal to. Okay, we wrote it here. If you multiply the first row by the second column and equating the first row, first column, you will see 1 multiplied by x is x, plus 3 multiplied by y is 3y. So 1x plus 3y equal 2. Okay, the next one. 4 multiplied by x is 4x. Negative 3 multiplied by y is negative 3. Then you should equating both sides. So it will be equal to 3. Okay, this one, my kids, is called what? Matrix equation. It's easy. For example, when you solve an equation, okay, sometimes you should find the inverse of some coefficient to isolate x or to isolate y. And here, my kids, in this case of matrix equation, also you should think of to inverse, okay, at the column vector or a matrix and so on. So we will decide which one we will find its inverse. So this is of the form AX equal B, where A, X, and B are matrices. Okay? With A, this is A, my kids. A is the matrix 2 by 2, 1, 3, 4, negative 3. And X is a column vector or is a matrix 2 by 1. And B is a matrix 2 by 1, which is equal to 3. Okay. So, we started from this equation and we wrote it as a matrix equation like that, a matrix multiplied by the x column vector equal to 3. Okay? Then, Okay. First of all, we want to isolate the column vector or the matrix X. Okay? XY. In our study of simple equation, we need inverses. We need inverses to isolate and to solve the equations. So, we do likewise when solving matrix equation. To isolate the unknown matrix xy, we must determine the inverse of the matrix A. Okay? For example, if A, the matrix A times the matrix X equal B, to find X, my kids, you should multiply both sides by the inverse of A. Good boy. We multiply by A negative 1 and here also by A negative 1. Okay. Then A negative 1 multiplied by what, my kids? By A multiplied by X should be equal to A negative 1 multiplied by B. Or, look here. A, the inverse of the matrix A multiplied by the inverse of matrix the inverse of matrix A multiplied by the matrix A is the unit matrix or identity matrix. So I will just write this one as Ix. Ix in fact is equal to X. Equal what? Equal A negative 1 multiplied by B. This is the solution of your matrix equation or of your simultaneous equation. Okay, let's do it, my kids. First of all, in order to solve this kind of equation, we told that Ax equal B. Okay, Ax equal B. This one. So we should find what? The inverse of this matrix A. Find the inverse of its matrix A, my kids. You already know how to find the determinant and how to find the inverse. So let A equal 1, 3, 4, negative 1. So the determinant of A is denoted as A between inside the absolute value. Equal what, my kids? Equal, look, 1 multiplied by negative 3 minus 3 multiplied by 4. Okay, 1 multiplied by negative 3, my kids, is negative 3. Minus 3 by 4 is negative 12. So, negative 3, negative 12 is negative 15. Okay. Now we try to work out the determinant, the inverse of the matrix. A negative 1, as you saw before, that is 1 divided by the determinant of A, multiplied by, we told the rearranging what? Rearranging the main diagram and change the sign of the next diagram, second diagonals. Okay, we told that 1 over A multiplied by the adjunct. This is called, do you remember? This is adjunct. Okay, it's a matrix. So, in order to find the adjunct, you should rearranging the main diagonals and here just changing the sign. So, where here? A equal what here in our example? A, where is the matrix? This is A, small a, I mean, small a equal 1, then small b equal 3, then small c, and small d equal negative 3. I will just write negative 3 here. So the inverse of the matrix is 1 divided by the determinant negative 15. Multiply negative 3, it will be here, negative 3, 1, and I will just put negative sign in front of the second diagonals. This is 3, 4, it will be negative 3, negative 4, negative 3, negative 4. This is, my kids, the inverse of the determinant, okay? So, the next. Now, as we found the inverse of matrix A, we should isolate X. Means what? Means, my kids, that you should write X as A negative 1 multiplied by B. Okay? And X is a column vector or is a matrix of order 2 by 1. In fact, is X y this one. Okay, so now this is the inverse of my matrix, 1 over 5. Okay, why 1 over 5? Look here, my kids. Because negative 1 divided by negative 15 multiplied by negative 3. This one gives what? Gives, this one gives 1 divided by 5. And 1 divided by negative 15 multiplied by negative 3 gives 1 divided by 5. Then 1 over negative 15 multiplied by negative 4 gives 4 divided by 15. And the next one, negative 1 divided by 15. This is the one, this is the inverse of my matrix A. Okay? Then, okay, so here my kids, we told that this is the inverse of my matrix. 1 over 5, 1 over 5, 4 over 15, negative 1 over 15. So it's also a 2 by 2 matrix. Okay? In fact, it's the matrix of it. Okay. And now, in order to find the value of x and y or solve for x, you should multiply the inverse matrix A by B. Okay? So, you will multiply the right hand side and left hand side by the inverse of the matrix to isolate x. Okay? This one, it will disappear, my kids. This one, it will written as identity. Okay? This is A, negative 1 multiplied by A, in fact, is identity or unit matrix. And a unit matrix is a unit matrix. Multiplied by any matrix gives the same matrix. So I will just write the column vector xy. Or I will just write what? I will just write what? I will just write the matrix of order 2 by 1. Okay. Then, okay, we done that. So, then, my kids, I will multiply the second one by what? I will multiply the second one by the same. So, this one, it will be cancelled out. Okay, so xy equal 1 over 5, 1 over 5, 4 over 15, negative 1 over 15 multiplied by what? By 2, 3. This is also is a matrix. Matrix multiplied by matrix, I will try to find 8. Okay? Look, 1 over 5 multiplied by 2 is 2 divided by 5. Plus, 1 over 5 multiplied by 3 is 3 divided by 5. Okay, the next one. Okay. 4 over 15 multiplied by 2 is 8 divided by 15. Negative 1 divided by 15 multiplied by 3 is negative 3 divided by 15. Then I will add. Okay. It will be what, my kids? This is written as E11, means the first row of the first column. This one is what? Is equal to, okay, this is in fact is E1, 1, and this is E2, 1. Okay? All of this is E2, 1, and this is E1, 1. Okay, I will calculate, my kids. 2 plus 3 all divided by 5 gives 1, 5 divided by 5 is 1, gives 1. Okay? Then, the next, 8 minus 3 is 5. 5 divided by 15 is 1 divided by 3. So this one, my kids, should be xy. If you want to equate both matrices, it will be x equal 1 and y equal 1 over 3. Okay? Look, E11 is this one multiplied by this. It will be 1 over 5 multiplied by 2, okay, plus 1 over 5 multiplied by 3. Okay, it will be what? This is 2 by 1 matrix, and this is 2 by 1 matrix, and this is 2 by 2 matrix, the inverse of matrix A. 2 divided by 5 plus 3 over 5 is 2 plus 3, all over 5. It gives 5 divided by 5, it gives 1. This one, kids. Okay. Then, e to 1 is what? E to 1, my kids. I will multiply the second one by the first column. The second row by the first column. Means my kids, 4 divided by 15 multiplied by 2. 4 divided by 15 multiplied by 2. Then plus negative. Plus negative is negative. So negative 1 over 15 multiplied by 3. Negative 1 over 15 multiplied by 3. This is I will make plus. So it's clear, plus plus negative is negative. Okay? So it will be what? 4 by 2 is 8 divided by 15. Minus 1 by 3 is 3 divided by 15. Both fractions, my kids, have the same denominator. So can I add or subtract both numerators? Okay. 8 minus 3 gives 5. 5 divided by 3.